Alright, so I'm currently on a little bit of a scuffed setup, so bear with me if everything looks a little bit different and no fancy transitions between monitors, but here. So today's day is going to have a good amount of coding, so I want to jump kind of quickly into it. But yeah, so basically for part one, we're just kind of doing the simulation and like kind of just processing it like that. So let's go ahead and start writing it. So first things first is I'm going to create a couple things. So first I'm going to create a module class. So class module def init, like a constructor is normal. So it's going to take in just a line. And then from this line, we'll go ahead and split it. And we'll split this on the little arrow that we get like here. So for example, if we get a line like this, I want to turn this into a module. So we'll have all of this. And then now, from here, if name is equal to broadcaster, this is the one like special case, then self.name is equal to names, self.type is equal to, and we'll just do a capital B. And then otherwise, we'll do else self.name is equal to everything except for the first character, because we have one of these symbols. And then we'll also do type is equal to just the first character like this. And then the other variables that we're going to have is, let me indent all of these. The other variables you want to have is our state. So how they're saying here is each variable basically has some state. Like for example, flip-flops will have this. And the other ones, it's fine to just have this, and you'll see why in a second. Works nicely for implementation. But then we'll also have our destinations, which is going to be equal to dest.split on the comma and a space. And so it's going to give me a list of basically A, B, and C. So cool. And then finally, we'll also record our inputs because we need to store those for this conjunction conjunction thing. And now we're going to create a class that uses these called a system for a system of these modules. And this is where basically all of our code is going to go into. So we're going to take in our input. And then from this, we're going to do self.modules is equal to, and we're going to do a dictionary comprehension. So it's like a list, but dictionary. So we'll do for m in map module input.split lines. So what this is doing is it's basically turning every single line into a module and then giving us this m. And then we're going to map it to m.name colon m. So now this basically gives me a ton of different modules. If I print out self.modules here, and then I'll go ahead and actually make a system. System on our input. Here you can see basically we're getting all of these things out. And so now from this, here, let's keep writing. So we'll do for m in self.modules.values. So for each module itself, because it's a dictionary, we want the module itself. We'll go ahead and for d in dest for each destination for each module, let's save that to the inputs. Name is equal to false. So inputs is the dictionary of every input and the last signal we've seen from this input. Now, for every module we see, go to its destination and say, hey, I'm one of your inputs, and by default, the last value you saw was false. They specify it here. They initially default to remembering a low pulse for each input. So this is how we do that part. So now that we have this, let's go ahead and that part's part two. They also said that they should be processed exactly in order. And so for this, we're going to create a queue. So self.queue is equal to a list. And we'll do self. And we'll also add self.pulses is equal to 0, 0 for scoring part one. Because we want to basically record how many high pulses and how many low pulses we've got. So with that, I believe we should be good. And just to save ourselves a little bit of time, we'll add also a variable just to see how many button presses we've done. So now we'll go ahead and create just a function to press the button. And so in here, self.button presses should increment by 1. And then also self.queue. So this should be empty. We'll just assume that. You can add an assertion if you want, but I already did and it was fine. And then our queue should basically take a from where, what is getting called, and what signal is there. So basically, this would be saying button is sending a false signal, so low signal, to broadcaster. And then now we'll do while we have a queue, we'll self.process and we'll just pop off the first thing we get. And then now, and we're also unpacking this operator. So we unpack three things. So we'll do def process, self, and this process should take a source, a name of a module we're processing, and the level of the signal. So self.pulses, first of all, at whatever our level we are at, plus equals 1. So if level is false, it'll correspond to the 0 index. And if it's true, it'll correspond to the 1 index, just because it gets automatically turned into an int when we try to index. All right, so now with that, we'll go ahead and try to get our module. So now we have the module object itself, and these should all be indented. Oops. With these modules themselves, let's go ahead and do each of our types. So if mod.type is equal to the percent symbol, we'll do something. If the mod type is equal to the and symbol, we'll do something else. And then the only other cases we have would be if it is the broadcaster. And then that's actually fine, because what we'll go ahead and do at the end here is basically we'll add 4d in mod des self.q.append main d mod.state. Alright, so let me basically explain what I'm going to do. In each of these loops, we're going to be modifying the mod state, so the module's state itself. And then finally, for every destination from this module, we're going to just go ahead and return that. And so the only times when this wouldn't happen is, for example, here they say flip-flops, if you get a high signal, you should do nothing. And they say that here. If you get a high pulse, it is ignored and nothing happens. So we'll do if, and if you're getting an infinite loop, this is probably what you're missing. This is what I was missing. If level is high, then we'll just return. We'll stop processing. We're done. So now, in here, if we didn't have a high level, this code will keep running, and mod.state is equal to not mod.state. So we basically just flip the module state. Now, for this ampersand, what we're going to do is a little bit more complicated. Mod.inputs source is equal to level. So we basically change the last thing we heard from source is now this level. And then mod state, so the value we're actually sending to all our children, will be not all mod.inputs.values. So what this is saying is for each input, all of the values, if they are all high, send a low value. If any of these is not high, this will be false, and then this changes it to a high signal. So now with all of that, we'll do, and then here we'll save something for part 2. But now from this, so if we have the broadcast signal, you can see here the default state is false, so it'll just send false, which is a low signal, to all of its children, which is what we want. So now let's go ahead and also create a scoring function. So for part 1, our score will just be return self.pulses 0 times self.pulses 1. We are just multiplying these together, I believe. And so we'll go s.press. Oh, and then also they want us to basically press the button 1,000 times. They say that here, 1,000 times. So we'll do for this in range 1,000, s.press button. Button press. And then finally we'll do s.score. And so let's go ahead and see what errors we have to debug. Alright, so that's a typo there. Let's change that. Int is not subscriptable. I need to return 2 things just because my test suite is like that. So part 1 is working. Part 2, the problem is, not part 1, test 1. But test 2, they give us this and they have an output node. And so we basically are just going to add that in as a dummy little node just to pad our kind of inputs to handle these test cases. And so what I did here is I did for empty in, and this is going to make sense why I have it like this. In a second, I'm going to make a tuple with just the string output in it. So this is just basically empty as output, that's it. Self.modules empty is equal to, and this is a little bit hacky, but I'm basically just defining a temporary module, and then self.modules empty dot des is equal to this. So basically I'm just making an empty module that has no children. So now if I run it, cool, it's no longer giving me any errors because it is now a valid module. So if I look here, I'm seeing this value, and the test case for this one should be that also. If I submit my code now, oh, it is complaining because there's a module Rx that is not defined. And if you look at your input, you should have something along the lines of this also. But, so what I did is I'm assuming, and actually if you get to part 2, you see every input has this Rx. So I'm just gonna add it to the empty modules that I'm adding for debugging. And so now I'm getting the right answer. All right, part 2. So for part 2, what I'm gonna do is, we basically wanna see when Rx gets its first low pulse. If you try to just run it, I'll give you a hint. This is my answer. You're not gonna have that code finished. So let's go ahead and look into this input a little bit more. So here you can see we basically just taken the inverted DD signal. On DD, we can see in a couple different places, but it looks like we're basically only taking, here, if I just go ahead and do this, I'll print s.modules dd.inputs. If I look at this, we see these 4 signals. And also, just because I'm kind of a little bit of a cheater, if you look through the solution thing, basically everyone sees this where there's 4 other nodes pointing, 4 inputs wired to Rx, stuff like that. So basically, for my input, and I'm assuming most inputs follow this structure, I have my Rx node get fed into by one other node, and that one other node takes 4 things. So essentially, because our Rx, if I look at Rx here, Rx is taking this inverted thing. When DD is getting all 4 inputs being true, that's our answer. And because we're getting something insanely high like this, first guess is just, it's probably cycles again. So let's go ahead and try detecting cycles. And also a lot of Advent code is going to be just, I have a hunch, let me try it. Yeah, like that's just kind of it. So this isn't something that's like foolproof, always guaranteed to work, but it's a reasonable guess, and it works in this case. So let's go ahead and start adding in the parts we need. So init, so in our init, let's go ahead. We have all of these modules here, all this, and we'll do self.parent. Let's get the parent of our root node. So self.modules rx.inputs.keys. So this is always going to be a dictionary with just one thing, because you're assuming all inputs are formed kind of similarly. So here, the input is only going to be this DD because there's no other RXs. So for this, I need to extract this to get just one element from here. I could either do something kind of disgusting, where I could basically unpack into one element like this by using what I like to horrify people by saying the comma equals operator, or we could do something lame like doing this, or we could do something like turn it into a list and get square bracket 0. But just because I want to be cruel, I'm going to go ahead and use this. So what this is doing, where was I? So what this is doing is basically just unpacking this thing with just one element in it into this variable. So now we have parent is going to be, in my case, DD. And then now from this, we want to be watching all 4 of its children. And we want to record when we first see it turn true in one of the loops. So we do self.listen is equal to none for n in self.modules, self.parent, inputs, keys. Also, if anyone's just trying to like follow along and write code as I do it, I'm basically staring at a second monitor, or in this case, my laptop, to write this code. So like this isn't representative of how normally I would write code. So don't like expect that. But yeah. So here we have our module. We're getting our parent. So in this case, the parent would be DD, and we look at its inputs and all the unique inputs. And for those, we're just going to store it into a list. So for example, here we're just going to store NX none, SP none, CC none, JQ none, so forth. What this is going to do is basically record none until it sees the variable send a low signal for the first time. And so if I go ahead now, and then one little addendum here is the inputs, like the test inputs, the only tests that they gave us don't have RX and stuff like that. And so if I just go ahead and try doing something like this, it's probably going to exception. Yeah, because it can't find RX. like it doesn't have any inputs to Rx because Rx doesn't exist. So just to make my code work on all of these test cases, I'm gonna add a little bit of ugly code by just adding this into a try except, and you can see we get a value error. So I'm just gonna catch that. I'll do self.parent is equal to none. Self.listen is equal to an empty dictionary. This is just so that my test cases still work. That's from this line down here. Now my test cases still work. So it's a little bit ugly, but yeah, we'll just assume that these are the only lines we care about. So now that we have those, let's go ahead and look into our process function. So in our process function, what we want to do here is we finally get to fill in this line. So if name is equal to self.parent, meaning we're looking at, in our case, dd, and for kv and self.listen.items for each kind of thing we're listening for, if v is none, so we haven't seen it already because we only want to save the first time we see it. So if v is none, and k is equal to source, meaning the node we're looking at is the one we're currently processing, and it's set to high signal, let's save that. And I was worried about an off by one error, but it turns out this works. So this is fine, and it's because I increment this immediately. But these are the values I wanted. It's a little bit of a shame they didn't give us any test cases, but can't complain. All right, so now we're basically saving whenever we first see each of these things. And then now we'll go ahead and we'll create a scoring function for part 2 also. So score 2, and we're going to do answer is equal to 0, and we'll return this answer. Sorry, make this 1, and 4. So for each period in here, for each like value in self.listen.values, answer times equals the actual value itself. And so we should only call this when all of these are not none. But so now let's go ahead and down here, and we'll do while while none is none in s.listen.values. So while there's still some node or like some parent, child, whatever node that we haven't seen yet, we'll keep going. So we'll call the button press, and then here we'll do s.score2. And then also, so the problem is this is going to keep running and then change our score. So let's go ahead and actually write down our p1 as s.score here, and then we'll do p1 like this. So now, test cases, doesn't matter, they don't have an Rx. If I run it on my actual submission, I get the right answer. So yeah, if you have any questions, let me know.